Morning, everybody, and thanks for joining us on our Easy Installation with OpenShift 4 webinar this morning. I'm Andy Kennedy, and I'm joined by John Cornforth, who heads our service delivery team, and he will be doing the bulk of the session. Just a little bit of intro, just a run through of what the agenda looks like for this morning. So we're expecting to be around 40-45 minutes. Just to start with, I'd like give you a brief introduction of Tier 2, so really why we are talking to you today about OpenShift. And then I'll hand over to John to talk about the main difference, a brief overview of OpenShift 4, really what the main differences are between 3 and 4, and then dive straight into some of the specific installation considerations and a demo. And we're demoing today on AWS. Just to wrap up then at the end, we're going to talk a little bit about how we might be able to help you kickstart your OpenShift initiatives, whether that's a proof of concept or just get going or whatever, and a few contact points as well. I don't think we're going to have too much time for sort of questions and so on the session. Is actually going to be quite full, but there are contact points and so on that we'll give at the end of it. And if you have any specific questions, please get in touch afterwards. Okay, so briefly about Tier 2 then. So in summary, we help organizations develop and deliver custom software. Increasingly, we are doing sort of using cloud native development approaches, and that typically is microservices deployed on containers. But as well as doing the web and mobile development work, we actually do a lot of enterprise integration work as well with the main Red Hat integration technologies. And increasingly, we're seeing that moving away from sort of centralized integration hub into more of a sort of an agile integration approach, again, sort of discrete sets of integration functionality deployed within their own containers. So we do end-to-end work with organizations, project end-to-end work, everything from analysis through design, development, and support. But some organizations, and particularly larger ones who've got their own development organizations, would rather use our skills in a more consultative capacity. So that tends to be for specific technical skills around the Red Hat middleware. Okay, so we were the first Red Hat premier middleware partner in the UK and Ireland. In the Red Hat world, partnership's not about the amount of software that we sell. It's actually about skills, accredited services, and so on. Today we're going to be talking specifically about OpenShift. And we have sort of accreditations and certifications in there as well. But as I was saying, we've come from a middleware background too, so we do have a lot of experience in delivering around the main Red Hat middleware technologies. That's specifically JBoss, Fuse, and AMQ, which is the integration technologies, and also process automation and rules in Red Hat's Process Automation Manager as well. So that's the briefest overview of Tier 2, just to give you a little bit of context on this, to say we do come from the middleware background, but the focus very much today is on OpenShift. So at this point, I'm going to hand over to John Cornforth.
Thanks, Andy, and morning, everybody. So I'm going to give you an overview of, first of all, an overview of OpenShift 4. Well, this is what it looks like. OpenShift 4 is now become the industry-leading enterprise Kubernetes platform. So I should imagine that most of you on here already know a little bit about what OpenShift is or what it's designed to do. You can see from this diagram here that it's a container platform designed to run on any infrastructure, whether that be physical, virtual, private or public cloud. At its heart is obviously Red Hat operating system. It's Core OS, which is a little different to maybe what you've been used to in previous iterations. Kubernetes is very much at the heart of it. That's really the core container platform, but with all the security that you would expect from Red Hat around the outside of that. And very much designed to give you both the best sort of IT operations experience in terms of monitoring and looking after the cluster, and obviously the best developer experience in terms of automating your deployments and developing very quickly. So the things that are specifically different with OpenShift 4 is, first of all, the fact that it's now available across the major cloud providers, all the real major cloud providers. So that includes Amazon, that includes Google, includes Azure, and Red Hat OpenStack, and quite a few others besides. As we'll see when we do our installation, you get to choose sort of where, which cloud you put your installation on. So as you saw in the diagram, Red Hat Core OS replaces the previous operating system for OpenShift, which was RHEL Atomic Host. Although it's not absolutely essential that you use Core OS for every part of the cluster, it is essential that you use it certainly for the control plane, for the master nodes. You can actually still provision standard RHEL images for your worker nodes if you want in your cluster, but effectively the operating system that underpins OpenShift is now Core OS. The other thing that's changed is the default container format. It's no longer Docker. Don't worry, Docker images are still supported, and we still deploy and run lots of Docker images within OpenShift, but the default container format is now the open standard CRI-O. Similarly, we're seeing gradually a move away from standard sort of Jenkins-based deployment pipelines. So our CI/CD, that's typically Jenkins, and there's a Jenkins build that's included as part of OpenShift, at least always has been. That's now being replaced by Tekton, which is a new sort of Kubernetes native means for doing deployments. So sort of deployment pipelines have been modernized and made a little bit more container native. A couple of other things specifically to us in terms of the installation for OpenShift. The first one is there's now full lifecycle management as of OpenShift 4. So OpenShift will work out what updates you can do and will allow you to do them via the web console. So it's much easier now to upgrade your cluster to a later version. And as I say, with the full lifecycle management, Red Hat will actually tell you where to go next in terms of cluster versions. And as we're going to see very shortly, the full stack installation, which includes the provisioning of the infrastructure on which OpenShift runs, can all be done with a single installation command. So it's a much more streamlined full stack installation. Any of you, and hopefully there's a few of you are on here who have wrestled with the installation of OpenShift 3, will find this rather a pleasant surprise. Okay, so as we're looking to install specifically on AWS, let's look at a few of the AWS specific considerations that we need to think about. The first thing is, do you want to provision the infrastructure yourself, or do you want the installer to do it for you? Because you have that choice now. As I say, the installation is very streamlined, particularly for AWS. So if you want to go away and provision all of your instances yourself, that's absolutely fine. You can do that, or you can have the installer do it for you. If you're gonna get the installer to do it for you, as we're going to in our demo, then you need to have an AWS account, and that account needs to have programmatic access. Which we'll see in a minute. We'll actually create a user with. We'll also see that the AWS account will need to be fully validated for the region where you are provisioning your resources. And I have actually fallen foul of that myself previously, where it took a long time to wait for my account to be validated for a particular region, provision of resources in the wrong region, as it turns out. The other thing we need to do is we need to make sure that we've got a dedicated public hosted zone in Route 53. Route 53 obviously is the DNS provider within Amazon AWS, and you need to make sure you've got a dedicated public hosted zone in there in which we can which we can place our resources. You can, if you have an existing domain registered somewhere else, transfer that to Route 53, and the documentation does give you guidance on how to do that. Yeah, you just need to make sure that you've got a domain available with a hosted zone in Route 53. Something else that I've fallen foul of previously is if you have multiple hosted zones in that domain, it can trip up the installer because it's kind of expecting you to only have one. So maybe something to just be a little bit careful about when you are doing your installation. Just make sure your AWS account or domain doesn't have multiple hosted zones, because you may find that the installer complains about that. The other thing to note is that this default installer provisioned infrastructure will always create 3 master nodes and 3 worker nodes. And as you can see from the slide there, that's the instance type that you're going to get. You're going to get M4 extra larges for the masters, and you're going to get M4 larges for the worker nodes. You can change that, but you'll need to create a custom installation config or custom installation manifest in order to do that. I'm going to show you how to do that as part of the demo. But if you don't create one of those and you go with the absolutely basic default install, then you will get 3 masters and 3 workers. So those are most of the sort of considerations for before you start with the installation. This is what I'm actually going to run through. I'm going to run through these steps in order. So we're going to create an IAM user within AWS with the appropriate API keys, and that'll give us all of the programmatic access to the Amazon resources that we need on our machine. We're also going to create an AWS profile, which just makes things a little bit easier for us so that we don't have to constantly retype the credentials or cut and paste the credentials for Amazon. And we're also going to create an SSH key, which will allow us to log in to our nodes once they're provisioned. This is all really just kind of getting our credentials, getting our accounts set up on our local machines so that we don't have to constantly rekey security information. We'll also be downloading some installation resources. So we'll need to download the installer. I'll show you where to get that from. We'll need to download the OC command for doing operations remotely on OpenShift. So we'll look at how we download and install that. We'll be doing a custom installation manifest, which is something I just mentioned a minute ago. This custom installation configuration that allows us to change how many workers and how many masters we have. Then I'll do the actual deployment. You'll see the deployment running, the cluster being created. And once that's done, there are a few sort of post-installation considerations, the main one of which is how we create users. So we'll look at that. We'll also go back and review the resources that have been provisioned in AWS. So we'll hop back into the AWS console and have a look at what's actually been set up for us by the installer. And finally, we'll just demo the installation with a quick deployment of and execution of an application. So let's get right on with it. First step here is creating a user with the appropriate API keys. Some of you may know that when you've got an AWS account, you have a sort of a root account. This is highly privileged, and it's the sort of thing that really you'd only use for things like your billing information and so on. It's kind of the most privileged AWS user. So we recommend, and indeed Red Hat recommend in their documentation, creating another user with a slightly lower level of privilege, which you can do with an IAM user in the AWS console. That IAM user must have programmatic access, which is basically just a box that you tick, and you must give it the right policies in order to be able to provision the infrastructure. All of these policies are wrapped up in a single administrator access policy. Now, you can go and manually add all of the individual sort of access rights that you need, but it's a very, very long list. The documentation does give you that list, by the way, but it's a very, very long list, and it's really only if you want to be very granular about the permissions that your Amazon user has. The easiest way is to just apply the administrator access policy right off the bat. When you create this user and you give it programmatic access, you'll get an access key ID and a secret access key, which you'll need to record for later use. Luckily, you can download those credentials in a CSV file, so that's one thing that we're going to do. And later on, we'll show you how to take the credentials that you downloaded and actually create your own Amazon profile so that you really never have to log into Amazon again. So let's have a look at that. I've got this in a form of a video, which I'm just going to play now to show you the setting of the IAM user. Here's the AWS Console, and we go into the IAM service. We're going into users. We're adding a user. I'm going to create this guy. It's going to be called OCP install. And here's the important box, programmatic access. So we're going to tick programmatic access and go on to permissions. And this is where we're going to add the administrator access. So we're not going to do anything with permission boundaries, that's fine. But here's the administrator access policy. We're going to give it that. We don't need to give it any tags. We'll review it at the end, and then we'll just go ahead and create that user. It's created it, and it's given us those 2 access keys that we're interested in. If we actually reveal the secret access key, we can see it there. And we just hit the download CSV button. You'll notice that down the bottom of the screen here, we've got a credentials.csv file that we've downloaded. So both the access key ID and the secret access key are downloaded to the local machine in that CSV file. And then I'll show you what to do with those later on. But that's basically the process for setting up the IAM user. Okay. So we're now going to take those credentials for that user that we've created, and we're going to put them in a profile on the local machine. You can do this in a couple of ways. If you're using the Amazon CLI for other things, the AWS CLI, then you have a command here, AWS configure, that will allow you to generate that profile. All you have to do is provide the credentials that were in the downloaded CSV. If you're not using the AWS CLI, you've got an alternative. You can create a file in your local directory under the .aws directory called credentials, and that effectively acts as the profile as well. All you have to do is put in your secret, your access key and your secret access key in there. I'll do it using the AWS configure. That's what you'll see in the demo. Now, the second thing that we'll do in this step is we'll create our own SSH key, which was really just used for logging into the nodes once they're provisioned. It's useful for debugging the installation, useful for disaster recovery. Hopefully that won't be necessary. And if we're on Linux, then we can use a very simple utility SSH keygen, which will just basically create a public-private key pair, which is used for logging in, SSHing into the nodes. So we'll have a look at this one too. Now on the screen here, you'll see I've actually already downloaded and installed the AWS CLI. This is the thing that gives me the AWS configure command that I'm going to use. I won't walk you through the CLI installation because it's pretty boring. But here's our credentials file. We've got that on the screen. That's the one we downloaded just from Amazon a minute ago. And here's AWS configure. And you can see it's prompting us for our access key and our secret access key ID. And once they're in, we don't need a region name. We also don't need an output format. We're just putting in those credentials. So now I have those credentials anytime I want to do anything with Amazon, those credentials are in there. Here's the SSH key generation. You'll see the utility SSH keygen, creates a public-private pair. That's what it looks like. It's the public key. If we actually look at the file that's been generated there, OCP install.pub, that's our public key. Okay. Just a bit of additional security steps that we require in order to make the installation a little bit easier for us. Just by the way, in doing that, we've saved ourselves a little bit of time as regards prompts from the installer. But if you don't do any of this, the installer will prompt you for this information. Yeah. So don't worry if you don't do all of this sort of the upfront security setup stuff. As long as you've got that user and you've got the credentials, then when you run the installer, it'll prompt you for those anyway. Okay, let's get the installation media now, we need to go to cloud.redhat.com in order to get these. And incidentally, when you do go to get these installation resources, you'll also be asked your cloud provider and your infrastructure type. So it's where we get to choose, yes, we're installing on Amazon, and yes, we're using the installer provisioned infrastructure. You will need a Red Hat login in order to go to this site. And when you do get there, you will be downloading both the installer software itself, the command line tools for OpenShift, so that's the OC command, and you'll also be given a pull secret, which is another bit of security, another sort of credential, which allows you to get the installed images, or the installer images, I should say, from Red Hat. Okay, so everything we've done as far as credentials up to now is really to do with Amazon. This bit, this pull secret, is so that we're allowed to get the images from Red Hat that we need to do the install. So we'll have a look at this one. It's pretty straightforward. We're logging into cloud.redhat.com. And obviously we'll do a little bit of password autofill, which will help us out. And here's where we get the choice of infrastructure provider. We're choosing AWS. And here's where we choose the installer provisioned infrastructure. So now it's just a case of downloading the 3 components we need. That's the installer software. Down it comes. There's the pull secret, which we need in order to have the permission to download images. And finally, the OC command line tools. You'll actually get OC and kubectl, but we don't use kubectl pretty much. We just use OC. Here's a file system, which is where those downloads have appeared. So first task will be to untar those tarballs. There we go. There's OC and kubectl. That's the tools. We then unpack the OpenShift install command. And finally, we're just going to move all 3 of those commands into our local bin directory so that they're always in our path and we can execute them from any location. Once they're moved, we'll just do a quick check to make sure that each of those commands do operate from the right place. And they do. So that's the process of getting the installation software that we need. Let's have a look now, before we actually kick off the install, let's have a look at this custom installation configuration. It's a YAML file. It's used to customize our install. And primarily, this is the thing that allows us to change the number of instances that we provision, the number of masters, the number of workers. Inside this file, you can include credentials such as the SSH key that we generated earlier and the pull secret for downloading images. This, again, just makes the installation process a bit quicker so that we don't have to respond to prompts. And this installation file can be created by hand. I'll show you an example of one we created by hand, but it can also be created by the installer itself. You'll see the command there, OpenShift install, create install config. So this will generate a vanilla installation config for us, and it will prompt us for the details that we need. So for example, those the SSH key information, pull secret, and so on. I had to stress, I've said this already, I have to stress that you don't need to create this file, because if we just run the installer right now without a custom installation config, the installer will prompt us for those details anyway, but it just makes life a little bit easier, particularly if we want to run multiple install commands or we want to tear down the install and then stand it up again. If we've already got that custom config file, it just makes life a lot easier for us. Incidentally, if you do want to change the number of masters and workers, then creating this file is the only way to do that during the installation process. Because if we just run the installer right now, we will get 3 masters and 3 workers, and we won't get a choice. So that's part of the reason why I think it's a good idea to create a custom install file before you proceed. Let's have a look at this one. So this is actually a sort of a hand cranked install config file. You see it's a YAML file with a particular format, and you'll notice that we've got the 2 workers and 3 masters here in this file. I'm actually just going to run the video now so that you can see the highlights. So we've got a domain that we put in there. We've changed the number of workers. We've got a cluster name of lab there. We've put in our AWS region. We've put in our SSH key, but we haven't as yet put in the pull secret. So what we're going to do here is just bring up the pull secret that we downloaded from Red Hat, and we're going to paste it into our custom install config file. So now we've basically got everything we need. We won't get any prompts, but everything we need to run the install. Let me show you the alternative to this. In the OpenShift install, you've got a create install config command, and it's prompting us here. So this is generating the custom file for us. We tell it it's AWS, we tell it it's the London region, we tell it what our domain is, what our cluster name is, and you notice because it's interactive, I can't go back into my pull secret file, so I've gone and got it off the screen. And what that gives us is a different install config file, and you'll notice when looking at this one that this has done the default number of workers and masters, so we've got 3 and 3 in each case. But of course, I don't have to use that one, and in fact, I'm not going to use that one. I'm going to use the one that we handcrafted earlier on, which has got just the 2 worker nodes in it. But that demonstrates that there are a couple of ways to create this, and quite possibly what you'll want to do is generate the install file and then customize it yourself. So now we've got all our credentials set up, we've got our install media, we've got our custom installation config file. There's really no escaping actually doing the install, so I'm going to do that install now. We run the installer with OpenShift install, and we use the create cluster command to create that cluster. We specify a directory location for the install. Obviously, that's not going to install it on your local machine, it's going to install it on AWS, but the location is useful for logs and other files that are created by the installer. It's also a location for your custom config file. Why is that useful? Well, because as I said earlier, you may want to rerun this installer. You may actually want to tear it all down. You may want to recreate the installation at a later date. And if you do that, it's going to be much easier to use the files that were generated by the installer than going in and trying to delete all the resources in AWS. Believe me, that is quite a painful process. So it's much easier if you want to do sort of tear downs and then spin the thing back up again to save those files in a custom location. So we'll do that. The installer also allows you to specify a log level, just so that you can see higher levels of log output if you want to while the installation process is running. So what the installer is going to do is going to go off and provision a bunch of resources in AWS, and that's going to take a little while. It's going to ping the API to make sure that the API is up. It's going to expose a route for the web console, and then finally it's going to tell us that the installation is successful. It's going to give us an admin user that we can log into. It's going to give us a URL for the web console and all that kind of stuff at the end. So let's have a look at what this actually looks like in practice. So I'm making this custom directory where I'm putting my custom config that I had earlier on. And then I do the OpenShift install create cluster command. I'm just going to back out the help there because I don't need that. I'm going to hit the button and off we go. So it's getting our credentials from our AWS profile. It's also loading our custom config, and it's off creating resources in Amazon. Bang, that's done. It's now pinging the API to check that that's up. That's done. You'll notice that we get a bootstrapping instance, which Amazon then throws away. Oh, sorry, the OpenShift installer throws away. So we create bootstrapping resources and then we destroy them. And finally, the cluster's up. Wow, look at that. The cluster's been provisioned. We've got a kube admin user with a password. That's the only way that we're going to be able to log into OpenShift at the moment, so we'll need to make a note of that. We've also got a URL, which gives us access to the web console, and you can see that URL here. So we can go in and we can log into our console. All looked a bit quick and painless, didn't it? Okay, well, shall I show you what it's really like? I'm going to basically rerun that command again. And it's doing the same things. It's going to get the Amazon credentials, load our custom config, start provisioning in Amazon. Okay, and now it's going to ping the API. Bootstrapping. Destroying the bootstrap. And initializing the cluster. And there you go, the cluster's up. So yeah, it's slightly silly, but that's my, I suppose, take on a real world installation. There is a bit of waiting around. I mean, in actual fact, it's not that painful. I've done this depending on sort of how quick Amazon is and what your internet connection is like and so on. I've done this in probably about an hour and a half, something like that. I think if you allow 1 to 2 hours for the whole thing to get stood up, that's a reasonable sort of estimation. But you'll notice that there's very little that you actually have to do. You just basically sit and wait for the Amazon resources to be provisioned. And I think you'll agree, those of you that have tried to stand up a cluster in OpenShift 3, that is much quicker. Before we move on to the user creation part of things, let me just show you what actually the console looks like. So when you've finished your installation, we'll go into the console. You will get this warning a couple of times about the self-signed certificates. The only user you can log in right now is kubeadmin. And you would need to have made a note from that installation output of what the kubeadmin password was. We log in and then we can do a brief tour of the console. But this is the cluster that was just provisioned by that installation process. So we get a few status updates there. We can go and have a look at what we've got. Got some projects already. Go and have a look at the compute resources that we've provisioned. So there are our nodes, our 5 nodes, our 2 workers, and our 3 masters, all provisioned in Amazon for us. We didn't have to give these names. We didn't have to do any of this. It all happened for us. You'll notice as well that at the moment there are no other users. This kubeadmin is basically designed to be a temporary user, and you're recommended to go and create your own sort of admin users. So there it is, a provisioned OpenShift cluster. Right, as I mentioned, the whole point about the kubeadmin user, it's the only user you get by default when you've installed your cluster. You need to set up some more. So in order to do that, we need to configure an identity provider. And there are lots of choices that you have here. You can do LDAP-based ones. You can do OAuth ones. You can use things like Red Hat Single Sign-On or Red Hat Identity Management to do this. But probably the simplest and easiest from day one is to just use an HT password file. It's basically just a flat file with a list of users and passwords. If you're going to create one of these, then the way that you sort of get it up into OpenShift is by creating what's called a custom resource definition, which is, again, another piece of YAML configuration. And you'll also need to generate the flat file that contains the users and passwords. Now, if you're on Red Hat Enterprise Linux, you can just do this with a command. There's an htpassword command that'll do this. And once you've done that, the flat file will need to be stored as an OpenShift secret. That's basically how OpenShift stores all of its credentials. So we'll basically go through that process of creating the custom resource definition, generating the flat file with the users in it, and then putting that flat file into an OpenShift secret. The other thing to just to mention when we're doing this is we're going to be using OC commands. So we're going to be interacting with our new cluster using the OC command line. And if we do that, it does help if we've got an environment variable in there called kubeconfig, which just avoids having to constantly log in to the OC command, log into our cluster via OC. Now, you don't need one of these. You're going to see this in the demo, but we don't need one of these. You can just do OC login and log yourself into the cluster and then do this. That's absolutely fine. But the kubeconfig environment variable just saves, again, a little bit of time. Another option that you have is you can actually do this via the web console. So when you've generated your password file or user and password file, you can upload that into the identity provider section of the web console, which might actually be a bit easier. We're going to do it the sort of the pure way with the OC command, but you can do it via the web console as well. Now, two things to remember here that are quite important with this. New users don't exist until they log in. So even though we will have run all of the config to set this up, you won't actually have the user yet until you've logged in with that user. And the second thing to note, which is particularly for our demo, once you've logged in as that user, you probably won't be able to see the list of users that you've created. And the reason for that is you won't have privileges to do that. So we'll have created a standard user, won't really have any privileges at all, so won't be able to see users. You'll need to have the cluster admin role in order to do that. So really, for your purposes, if you're going to create your own cluster admins, which you're recommended to do, you'll need to do the whole of this process, which includes creating the identity provider with the password file, logging in as that user, and granting that user cluster admin privileges. So we're going to do basically all of that as part of our demo. So let's just have a look at that demo. So there's the kubeconfig environment variable, which just avoids us having to log in to OC. Right, here's the custom resource definition. You can see there it's an OAuth type and it's an identity provider. We're going to use htpassword as our type of identity provider, and the important bit here, the password file, the file data there is htpass secret. So that's actually the name of the secret which is going to house our password file. So just highlight it there. That's the name of our identity provider, the type, and the secret that we're going to use. So here's the htpassword command, which is a Linux utility just for generating passwords. We've created a user called mhamzakhan, and we've given it a password. We're now applying that YAML, that custom resource definition. You could do this actually before or after you put the password file in a secret, but our last step here is we're going to put the password file into a secret using the OC create secret command. Right. You'll notice in our console, if we go and have a look at users, that even though we've done that, we still don't have any users. We have no list of users yet because we haven't logged in as that new user. You'll notice as well a choice there. We could log in now as kubeadmin or as a local user. So we're going to log in as our mhamzakhan user. And hey presto, we've logged him in. Now, of course, this user can't see a list of users. So we still don't have that list of users that we're kind of desperately craving, because the last step in this whole process is to grant this new user cluster admin rights, which we do with that admin policy command there. So now the mhamzakhan user should have cluster admin, which means if we refresh our console, we now have the user management section with a list of users, and we can actually see our new user. So a little bit of an intricate process there. And as I say, you may find it easier to actually just upload that HT password file into the web console. But you'll need to go through the process of creating the identity provider with the password file, logging in as that user, and then giving him cluster admin access in order to actually create yourself a new cluster admin user of your own. All right, so let's go back now into AWS and have a look at the resources that have been provisioned for us. Let's go and have a look at how much money we've given to Jeff Bezos. So in Route 53, what we'll find is we've got a couple of DNS records, new DNS records in our root domain, in our tier 2 consulting, tier 2 OpenShift.co.uk domain. We've got an API DNS record and a star.apps DNS record. And as their name suggests, the API record is for the OpenShift API. And the star.apps is for any applications that we want to expose via the OpenShift cluster. And both of those DNS records, as you'll see in a moment, point to external elastic load balancers that have been provisioned in Amazon for us. We'll also see an additional subdomain under the root domain, which is a private internal only subdomain. It's called lab. In this case, the DNS record here points to an internal elastic load balancer. We'll still see a reference in this domain, by the way, to the external endpoint for applications, which is the star.apps, and that still points to the same external load balancer. But the key here is that we have an additional internal DNS record just for internal API traffic. What we'll also see in EC2 is our 3 masters and 2 workers being created. Now, we saw that briefly in the OpenShift console, but we'll actually see it in AWS itself. We'll also see our discarded Bootstrap resource, our Bootstrap instance, which is basically stood up and then shut down because we don't need it anymore. And we'll also see our 3 elastic load balancers, the 2 public-facing ones and the 1 internal one. So let's go and have a look at that. We'll do a quick tour of the AWS console. So in our Route 53 DNS service, although it's got 3 hosted zones there, we've actually just got the one that we need, the tier 2 one, and the one at the bottom we'll look at in a minute, the one that was created for us. There are the 2 new DNS records, the API lab and the star.apps lab, and just have a look at the references, the aliases that it points to. That LabX and the AK777, they are the external load balancers, and we're going to see them in a moment. If we go into the lab, we'll see that there's an additional API reference, API lab tier 2 OpenShift, and that's again pointing to the internal elastic load balancer. And there's the reference to the applications, the AK77, which is the external load balancer. So that is our internal DNS. We go into EC2. And before we see our instances, we'll need to go into the right zone. So we go to London. And we should see 6 instances because we'll have our 3 masters and 2 workers, but also the terminated Bootstrap instance, which has been discarded. Notice they're spread across different availability zones, which is always helpful, those instances. And then finally, if we go and have a look at our load balancers, we should see 3 elastic load balancers. 2 are public facing, the top 2, and 1 is internal. And there is a difference there between the top one for applications, which is the AK77, and the external load balancer, because they actually point to different ports. They deal with different traffic. Just to prove that that matches up, here's a reminder of our DNS entries. This is just the internal DNS records. They match up with the names that we can see here for these load balancers. There's our instances. And if you notice the traffic there for the application load balancer, you'll see, I'm just going to wind this back so that you can see it clearly. There's the traffic for the application external load balancer, which is just standard web traffic 443 and 80. So that's a classic load balancer. And then if you look at the other one, then the listeners on here is port 6443, which is the OpenShift API endpoint. So those are the resources that were created in AWS. We didn't have to do any of that manually. The installer did it all for us. And then finally, just to round off the demo, I'm going to show you a quick application deployment in our brand new cluster. So we can go ahead and create applications either via the web console or through OC, expose external routes to those applications, scale them up and down. And in our example, we're just using a Who Am I image from which Who Am I app, a very simple app from Docker Hub. Of course, using Docker Hub images, that's absolutely fine. But really, in a sort of production environment, you'd be recommended to use Red Hat certified images, which you can get from catalog.redhat.com. So let's have a quick look at that. So we're going to use the OC new app command to create a new application. We're just using that Who Am I image from Docker Hub, and the application isn't yet exposed externally. So we're going to use OC expose, which exposes the service as a root. We're going to use OC status to see the status of the application, and that will show us the various components, the deployment config and so on. And we can see these in the web console. So there's our deployment config. We've got one running pod. That's the running pod at the moment. And if we go into our routes, we can see there's the route that we've exposed to the application. Click on the URL. There's our running application already provisioned for us. And then if we go back in, have a look at our deployment config again, we can scale this up. So instead of one pod, we actually want 3. We'll go and look at our pods. We'll see 2 new pods being created, and now they're running. So we've got 3 instances of the application. And then, of course, we can just scale it down again. And the running pods come right back down to 1. So there you have it. An application deployed on a brand new OpenShift cluster that was provisioned for us by the OpenShift installation process. That's the end of the demo. So I'm going to hand back over to Andy now.
Thanks, John. So as I mentioned at the top of the webinar, this was the 3rd in the series of OpenShift related webinars. It's all around what we're calling quick wins. And that's just to show you that, as John was demonstrating there, that, well, of course, requirements need to be clearly understood and implementation planned properly and all those important things. But we can be planning these types of things in terms of, in terms of days, and rather than previously in terms of weeks and months. So that's really what we're trying to get across there. There's a web link on there to our insights, our blog post on the website. The first 2 webinars are up there at the minute. They were related to reporting or rehosting on-premise applications up into OpenShift, and the second one was all around deployment pipelines. A recording of this webinar will be up there this afternoon as well. So please use that as a very useful reference, if you need to. Very, very conscious of time, actually. We're quite tight on that. What we just wanted to briefly outline today was that we do have a sort of Kickstarter initiative, if you like, and that's really around just really helping you get up and running, and that might mean, an initial installation, or potentially you're thinking about a proof of concept or whatever. And what we're doing is we're offering very heavily discounted consultancy, up to 5 days of that, which complements a sort of a Red Hat 60-day OpenShift evaluation that you get, which itself is self-supported. So again, at the end of this, we'll be in touch. We can very, very happily talk to you about what your requirements might look like, and if that's something that is of interest to you. As a final point, then, just a few contact details. If we don't get you first, there's some technical contacts on there. So that's John's email address. So anything that you'd like to clarify with John, please drop him an email. And as I say, we will be reaching out to you anyway. But if you'd like to, to talk more to us about, anything related to the OpenShift webinars we talked about, your particular requirements or whatever, please drop us an email at sales@tier2consulting.com, and we'll be very, very happy to talk to you. For the moment, big thanks to John for doing that. There's a lot of content in there. Hopefully you find it all very useful. Thanks everybody for joining this morning, and I hope the rest of your day is a good one, and we'll be in touch soon. Thanks very much again.